Notations for fuzzy sets. Welcome to Fuzzy Mathematics, the Basics. In the previous lectures, we have talked about fuzzy sets and their membership functions. A fuzzy set A is characterized by its membership function from the universal set to the closed interval from 0 to 1. For each element x, the degree of membership of x in fuzzy set A is mu sub A of x. In this lecture, we are going to introduce three types of notations for fuzzy sets: Jardine notation, ordered pair notation, and fuzzy vector notation. First, Jardine notation. Let X be the universal set. Let X be the set of x1, x2, all the way up to xm. Set X is finite. Let A be a fuzzy set in X. Suppose that for each element xi, the degree of membership of xi in A is mu sub A of xi. Then we can write as follows. The fuzzy set A equals mu sub A of x1 over x1 plus mu sub A of x2 over x2 plus all the way up to mu sub A of xm over xm. It should be noted that the plus sign here has nothing to do with addition, and the formula on the right does not indicate the arithmetic sum. The formula on the right may be viewed as a union or a summation of the elements and the degrees of their membership. If there is an element such that its degree of membership is 0, then the corresponding term could be omitted. If a fuzzy set A is defined on a universal set which is finite, then we can also write as follows. The fuzzy set A equals the summation I equals 1 to m mu sub A of xi over xi. If A is a fuzzy set defined on a universal set which is countable, we can write as follows. The fuzzy set A equals the summation I equals 1 to infinity mu sub A of xi over xi. Also, it should be noted that the capital sigma does not indicate addition or the arithmetic sum. Next, suppose X is the set of real numbers or an interval of real numbers. If A is a fuzzy set in X, then we can write as follows. The fuzzy set A equals the integral over the universal set, mu sub A of x over x. It should also be noted that the integral sign here has nothing to do with integration. The formula on the right can be viewed as a union of the elements and their degrees of membership. We have known that a crisp set is also a fuzzy set. To be consistent with the notations here, a crisp set can be denoted with Jardine notations as well. Example 1. Suppose A is the set of A, B, and C. Set A is a crisp set. It can be written as follows. A equals 1 over A plus 1 over B plus 1 over C, because the degree of membership of each element in A is 100%. Next, ordered pair notation. Let X be the universal set. Let A be a fuzzy set in X. The fuzzy set A can be expressed by the collection of ordered pairs, where the first part of the pair is element X from the universal set, and the second part of the pair is the degree of membership of X. If the universal set X is finite, then the fuzzy set A can be written as follows. Fuzzy set A equals the collection of ordered pairs x1, mu sub A of x1, x2, mu sub a of x2, all the way up to xm, mu sub a of xm. If there is an element such that its degree of membership is 0, as in the case of Jardine notation, then the corresponding term could be omitted. Next, fuzzy vector notation. Suppose the universal set X is finite. Fuzzy set A can be written as follows. Fuzzy set A equals an ordered n-tuple, where mu sub A of x1 is the first element, mu sub A of x2 is the second element, mu sub A of xn is the nth element. And the ordered n-tuple is called a fuzzy vector, because a set is a collection of unordered elements. The elements in the universal set are unordered. But if you want to express a fuzzy set by a fuzzy vector, then the elements in the universal set should have sort of default order or some sort of natural order. And it should be noted that even if there exists an element such that its degree of membership is 0, the corresponding term could not be omitted. Now we have introduced the 3 types of notations for fuzzy sets. Let's do some examples. Example 2. Suppose X is the set of 1, 2, 3, 4, 5, 6, 7, 8, 9. Here X is the universal set. Let A be the set neighbors of 5. If the set neighbors of 5 is considered to be a crisp set, then 5 is a neighbor of 5, 4 is a neighbor of 5, 6 is also a neighbor of 5. Each of these 3 elements has 100% membership. If the set neighbors of 5 is considered to be a fuzzy set, then we have to list all the elements and their degrees of membership. Of course, 4, 5, 6 are neighbors of 5 100%. 3 is also a neighbor of 5, but not 100%, say 70%. 7 is a neighbor of 5, 70%. 2 is a neighbor of 5, 30%. 8 is a neighbor of 5, 30%. 1 is not a neighbor of 5. 9 is not a neighbor of 5. Use Jardine notation, ordered pair notation, and fuzzy vector notation to denote fuzzy set A. First, Jardine notation. Using Jardine notation, the fuzzy set A equals 0 over 1 plus 0.3 over 2 plus 0.7 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 0.7 over 7 plus 0.3 over 8 plus 0 over 9. As the degree of membership of 1 is 0, and the degree of membership of 9 is also 0, the first term and the last term on the right could be omitted. Next, ordered pair notation. With the ordered pair notation, the fuzzy set A equals the collection of ordered pairs, such that the first part of the pair is the numbers in the universal set, and the second part is its degree of membership. As the degree of membership of 1 is 0, the degree of membership of 9 is also 0. The first term and the last term on the right could be omitted. Next, fuzzy vector notation. With the fuzzy vector notation, the fuzzy set A equals an ordered n-tuple. Here the elements in the universal set X should have sort of natural order from 1 to 9. Even if the degree of membership of 1 is 0, the degree of membership of 9 is 0. the first term and the last term on the right could not be omitted. Another example, example 3. Let the universal set be the set of real numbers. Let A be the fuzzy set much larger than 5. The membership function of A is as follows. Mu sub A of x equals 0 if x is less than or equal to 5. Mu sub A of x equals the reciprocal of the quantity 1 plus 10 over x minus 5 squared. If x is greater than 5, use steady notation to denote fuzzy set A. The fuzzy set A equals the integral over the set of real numbers, mu sub A of x over x, and the membership function is illustrated here. If x is less than or equal to 5, the degree of membership of x in A is 0. If x is greater than 5, the degree of membership of x increases rapidly as x goes to infinity. In this lecture, we have introduced 3 types of notations for fuzzy sets: Jardine notation, ordered pair notation, and fuzzy vector notation. Next time, we are going to talk about the relations between fuzzy sets. Thank you.